Assalamu alaikum guys, welcome back to another lecture of digital signal and processing. My name is Khurram Aziz and my roll number is 16T59. और आज के लेक्चर में हम पढ़ेंगे filters, digital filters and moving averaging filters. So this is going to be pretty boring or fun, depends on your mood. अच्छा, तो सबसे पहले हम पढ़ेंगे what is a filter. Filter is a device that removes unwanted components from the signal. ठीक है जी, जो गंद बला होता है उसको रिमूव करने के लिए इस्तेमाल किया जाता है. जो अनवांटेड नॉइज, एनीथिंग दैट यू वांट टू रिमूव, इट विल ओनली अलाउ अ सर्टेन अमाउंट ऑफ frequencies to pass. The next thing we have is a digital filter. So what is a digital filter? It is a system that performs mathematical operations. Because of the word digital, you should already know that it will perform mathematical operations on a sampled discrete time signal to reduce or enhance certain aspect of that signal. So this is a very uh, high performance filter. The next thing, इसके uses क्या है? सिग्नल सेपरेशन के लिए इस्तेमाल किया जाता है, in which we have two signals that are to be separated. अब वो कौन से टू सिग्नल्स हो सकते हैं? फॉर एग्जांपल इन एमआरआई, जब एमआरआई हो रहा था फॉर अ प्रेग्नेंट वुमन, तो तब क्या होता है कि जो हार्ट बीट ऑफ द चाइल्ड होती है ना, इन ऑर्डर टू गैस वेदर इट्स मतलब देयर इज़ नथिंग बैड गोइंग ऑन, ताकि पता चले कि इज़ द चाइल्ड हेल्दी और नॉट, तब वो ये डिजिटल फिल्टर इस्तेमाल करते हैं ताकि बच्चे की हार्ट बीट को डिफ्रेंशिएट किया जाए फ्रॉम द मदर्स हार्ट बीट. So the next thing is when the signal has interference, obviously there's gonna be interference, there will be interference of the breathing of the mother, the heartbeat of the mother itself, and other processes which are happening throughout her body. So उससे हम बच्चे की heartbeat को अलग identify करते हैं. So the next thing is signal restoration. So used when the signal is distorted in some way. For example, if you are sending or transmitting a specific signal and you get it on the receiver side, then you have to make the original signal as it was transmitted, reproduce it. So उस केस में हम जब अगर वो, क्योंकि डिस्टॉर्शन ऑब्वियसली आएगा चैनल की वजह से, तो उसकी रेस्टोरेशन के लिए हमने डिजिटल फिल्टर्स इस्तेमाल करते हैं. So the next thing is the fight of the century, analog filter versus digital filters, bigger than the end game. So here we have the analog filters. These are cheap, as in saste, or fast, large dynamic range of frequency and amplitude, but their downfall is that their performance is very low, that they do not match up to the digital filters. Digital filters are not that cheap, obviously. They might depend upon their execution time, might depend upon the signal which are we providing to them, and the system on which they are running, but they are superior in performance. They give quite good results. That's why most of the time digital filters are often preferred. और आप ये हिसाब लगा सकते हैं कि देखें, obviously these are cheap, fast and large dynamic range, but due to their poor performance they are not used. So information representation, there are two domains in basic DSP, which are frequency domain and time domain, in which the information is represented. For example, टाइम डोमेन में अगर हमने एक से अच्छे फिल्टर की आइडेंटिफिकेशन करनी हो तो हमें कैसे पता चलेगा? इफ़ he has the following characteristics, it is a good filter. So if the step response is fast, as you can see the step response is pretty slow, it's happening over a large time interval here to here. So this should be something like this, pretty fast. This is a bit distorted. हाँ, मतलब कि इसका जो step response है, this should be quick. So the next thing is no overshoot. Here you can see there is some bits of overshoot. So a good filter provides less overshoot. The second thing is the linear phase. Here you can see that the phase is not linear itself. Here is some distortion happening, or the phase itself is not linear. These are not same. अगर ये same हो तो फिर linear होता है. For example, something like this. These two practically look the same, but what I want to convey that is कि इसके अंदर how it starts should be the same as to how it ends. मतलब कि ये सेम होना चाहिए, लीनियर होना चाहिए, then it will have a linear phase. The next thing is the frequency domain. The second dimension or the second domain in which we study signals is the frequency domain. Now the first thing that we need to have in a filter is a fast roll off. उसकी roll off frequency काफ़ी ज़्यादा होनी चाहिए. This means that it has a quite good roll off. This you can see that has poor roll off. This takes a large interval of time. It should be something like this, quick to here. I have drawn it a bit weird or whatever. हाँ, तो ये इसका roll off time कम होना चाहिए as compared to this. The second thing is flat pass band. Here you can see that the pass band is not flat itself. Here you have the stop band. The flat pass band is a minimum requirement. Just like in this, it has a flat pass band, so it should also have a good filter should provide flat pass band. The next thing is good stop band attenuation. The attenuation here is pretty poor. The attenuation should be very less, the attenuation provided. So here it should have less attenuation. It should be something like this. There should be very less attenuation. Here's 0. These are minus 20 dB and minus 40, and what else? So the difference between the attenuation should be very less. The next thing we have on our hands is the types of filter. Now there are basic 4 types of filters. पहले हमारे पास जो type आती है, these are the low pass filters. The low pass filters allow, so the low pass filter, what it does is, जो छोटी frequencies होती हैं, the lower frequencies, it allows the smaller frequency to pass. छोटी frequencies को ये pass होने देता है, and then stops the higher frequencies. Here you can see the stop band. Here you can see the pass band. यहाँ हमारे पास frequency low होगी. Here is 0, the reference point. So as it moves on, it allows the lower frequencies and stops the higher frequencies. So here what we have is called a transition band. Here the transition is occurring. यहाँ वो lower से high frequencies या जितनी आपने limit apply की होगी उस phase से गुजर रहा है. That's why we have a inclination. The next thing is high pass filters. In high pass filters, as you know, it is opposite of the low pass. It stops the required or the given amount of lower frequencies and allows the higher frequency. This is what we call a pass band, and this is the transition phase happening, and this is the stop band itself. So the lower frequencies are stopped, the higher are allowed, and this what we have is the transition between the lower phase to the higher phase of the frequency. Now the next thing is band pass. अगर हम चाहते हैं कि a specific amount of frequency, for example around about 50 to 100 hertz are only allowed to pass, then we apply a band pass filter, because it specifies the limit to which to the amount of which the signal should be allowed to pass. So it limitizes. Here we have some lower frequency being blocked in the stop band. This is the stop band, and this is the pass. This is the stop band for higher frequencies. So it is basically the convolution. As you can see that if we convolve these two filters, we will have the band pass filters. So the next thing is the band reject filter. It is just the opposite of the band pass. It blocks the given amount of frequencies. For example 50 to 100 अगर हम block करवाना चाहते हैं, so then it will block the required frequencies and allow the lower and the higher frequency to pass. This is the pass band. By the way, it will have two transition phases because of the stopping the frequency phases up to a certain level, then stopping the higher frequency up to a certain level, because this is why it will have two transition bands. So this also have two transition bands because it will reject a certain amount from lower to higher. So the next thing we're going to study is the moving averaging filter. So the definition is the filter operates by averaging the number of points from input signal to produce the output signal. These are very easy to design, बड़े simple होते हैं, simple filters हैं, implemented by convolution, so that's always a plus point. And there's always a plus point, sorry for the pronunciation. And the next thing is we have the formula of how convolution works while implementing these filters. So what are their uses? They are used for noise reduction. For example, the original signal is large, then if we apply 11 point moving filter, moving averaging filter, it will average 11 points across these crust and troughs and will provide us with a rather smooth filter. And if we 11 point means that 11 pulses were used in the impulse response h of n. So if we apply 51 point moving averaging filter, then our result will be quite smooth, but we will have to experience slow step response. So this is always a trade-off. You can't have best of both worlds in this case. So यहाँ हमारे पास slow step response होगा. This means the result will be very delayed. There will be a large amount of delay added due to the slow step response. So this is why we take some mid-range value. This was all for this lecture. Thank you for joining. Peace.